All right, so today you're at home having a good time. I have one lesson for you to do, three examples, and then maybe a little practice. So take a look at this video. Bring all your questions on Monday. I'll be happy to answer them. But today's video is on elimination. And so far, we've done two things already. We've done graphing, where we have graphed each equation and looked for where they intersect. And that's our solution, right? And we said they could be parallel, which there would be no solution. And we said they could be the same line, which would mean they'd have infinite solutions. We've done substitution as well. And with substitution, it's the same deal. We could find that there is one solution where the two lines intersect. In the one video that I posted on substitution, you'd see that there are infinite solutions, and that is like if you get something like this, negative 10 equals negative 10, that means that there's infinite solutions. And then the one I didn't go over is what if you had something like negative 10 equals 5? Well, that's not true. So if that happens, then that means that there would be no solutions. And we're going to talk about each of those today using the new method called elimination. So here's our first example. You can find all these examples in the PDF file in today's folder, Wednesday, February 17th. By the way, happy St. Patrick's Day. And you follow along and take your notes as you'd like. All right? So here's our first example. This is an example where we would get one solution. Like I said, we're going to go through all three, but this gives us one solution. So first, let's talk about what it means to eliminate. Elimination means to get rid of. Well, what are we getting rid of in one of these equations? Elimination means to get rid of an x or a y. All right? The way we do that is by making the x coefficient and the y coefficient the exact same, but one's positive, one's negative. Now by coefficients, let's clarify what I mean. Coefficients are the numbers in front. So the coefficient in the first equation for x would be 7, and the coefficient of y would be 2. The coefficient in the second equation for x would be 8, and the coefficient of y would be 2. It's the number in front of the variable. Okay? So that's what I'm talking about when I say coefficient. So an example would be, I want one to be negative 4x and the other to be positive 4x, so that when I add them together, they go to be 0. So that is the goal for elimination. If it's not already set up to be like that, then we create it to be like that by multiplying by something. So we're going to look at this example here. We have 7x plus 2y equals 24, and 8x plus 2y equals 30. Hopefully what you notice right away is that the y values are really close to being opposites. They're both the number 2. So I'm going to choose to eliminate y. Now, how are we going to do that? Remember, we need one to be positive, one to be negative in order for them to go to 0. So you could choose whichever one you want. I'm just going to choose the top one. And the way we get this top one to become a negative 2 is we multiply it everything by negative 1. So we're going to eliminate the y by multiplying the top equation by negative 1. So negative 1 goes outside. And what we have to remember to do is to distribute that negative 1 to every single term. So we would have negative 7x minus 2y equals negative 24. Now, we didn't do anything to this bottom one, so we're going to keep that as is. 8x plus 2y equals 30. Once we're set up, now we're going to add down. So I have negative 7x plus 8x leaves me with 1x. Negative 2y plus 2y gives us 0, which was our goal. And then we have negative 24 plus 30 is 6. So our x value is 6. If for some reason you were add these together and you still have both x and y, then that means you multiplied incorrectly. So once we have x, now like the other problems, we have to go back and find y. You can use either one of these equations, 7x plus 2y equals 24, or we can use 8x plus 2y equals 30. It does not matter. And just because I'm going to choose the top one, so I'm going to say 7. I know x is 6, so I'm going to take out the x, put 6 in its place, plus 2y equals 24. And I only have to do that for the top one, because this is now going to solve for y. And again, I follow my order of operations. 7 times 6, I believe, is 42. Whoops. And that equals plus 2y equals 24. Subtract 42 from each side. Let's see if I could get my math right here. I think it's 18, negative 18. Somebody double check that. Maybe I'm wrong. And then our last step, like in almost every other problem, is to divide. So y equals negative 9. And just like the others, we write it as an ordered pair. 6, negative 9 is our solution. There is one solution. Like we said, it is where the two lines cross if we were to graph them, and that point is at 6, negative 9. All right, so we just did what one solution looks like. What would it look like if there is no solutions and we were eliminating? So remember, our whole goal of elimination is to get rid of one of the variables, either x or y. So let's look at this equation and figure out which one might it be easier to get rid of. So I have a 2x and a 3x, and we have a negative 6y and a negative 9y. Now my brain thinks I'm going to go with the smaller numbers, and hopefully yours does too. I always pick the smaller numbers, so I'm going to choose to get rid of the x. So how am I going to get rid of the x? Because one has a 3 and one has a 2. So we're going to think about those two numbers, and what are multiples of 2? Multiples means, let's go in order, 2 times 1, 2 times 2, 2 times 3. So 2 times 1 would be 2, 2 times 2 would be 4, 2 times 3 would be 6, times 4 would be 8, and let's go times 5 would be 10. And we're going to do the same thing for the other x, but it's going to be 3. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, and 3 times 5 is 15. What was the purpose of doing that? It was to figure out what is the common multiple that they have. And the one that they have in common is the 6. So that's what we are going to try to get each of them to become. So in the top equation, it was a 2. To get that 2x to become a 6, we multiply it by 3. And remember, when I multiply, I not only multiply that first one, but I multiply the second term, and we multiply the last term. So I have a 6x here, positive. That means my next one, when I multiply, should be a negative 6 because I want them to be opposites. So I'm going to multiply the bottom equation. If I want this 3 to become a 2, I'm going to multiply it by 3 to become a 6, I'm going to multiply it by 2, but also a negative so that they're going to be opposite signs. Distribute. Use your calculator if you need to. And there we go. So notice, if I try to add down now, 6x minus 6x, yes, went to 0. Negative 18y plus negative 18y, plus 18y, negative 18y plus 18y. Uh-oh, that also goes to 0. So I'm left with nothing on the left. And on the right, I have 15 minus 4, which is 11. Is 0 equal to 11? That is false. That is why there is no solution. Again, pulling it all together by what we did when we graphed. If we were to graph this, you guys did a great job on your homework quiz. The graph would look like that. They would never cross. All right, hopefully you guys are still with me. We have one more to get through. What would it look like if there were infinite solutions? So again, we look at our system. I'm going to take a look at my x's, and I'm going to take a look at my y's. And I'm going to say, okay, is there one that's smaller than the other? And I think it's pretty obvious that the x's have a smaller coefficient, so we're going to focus on the x's. So let's look at those. We have a 2 and we have a negative 5. Perfect. One's positive, one's negative. Like the last one, we don't have to worry about positive and negative because they already are set up that way. We just have to worry about what's the multiple that they have in common. So again, I'm going to list them. 2 times 1 is 2. 2 times 2 is 4. Times 3 is 6. Times 4 is 8. Times 5 is 10. I'm just going to keep it at positive 5 here. 5 times 1 is 5. Times 2 is 10. Times 3 is 15. Times 4 is 20. And times 5 is 25. Now, if you notice, as you're writing them, oh, this is the one they have in common, then you can stop. So they both have 10 in common, so that's their least common multiple. So now we know that we want each one to become a 10. So we're going to multiply the top one. 2 times what gives us 10, and that would be a 5. And we're going to distribute that in to every term, just like we did with the last one. Now we're going to do the same thing, but with the bottom one. Now again, negative 5 times what will give me 10, and it's going to be a 2. We do not have to worry about multiplying by a negative because it's already a negative 5. So we get 2 times negative 5 is negative 10x. 2 times negative 20 is negative 40y. And 2 times negative 15 is negative 30. Now, just like the others, we're going to add down. Hopefully, our elimination works. 10x minus 10x, all right, goes to 0. 40y plus negative 40y, oh, that also goes to 0, so we're left with 0 on the left. 30 plus negative 30, oh, that also goes to 0. We got all these zeros here. Is 0 equal to 0? That would be a yes. That means there are infinite solutions. So in the last one we said there's no solutions because it was false. X's went to 0, Y's went to 0, and we had a number on the other side. That was no solution. In this case, every single part went to 0, so this is infinite solutions. What that would look like on a graph is you put one line, and when you graph the other line, it's right on top of it. It's the exact same line. That's why there's infinite solutions. You guys, I appreciate you watching this video. I hope this helped you. I hope you took notes. Again, bring your questions on Monday. I hope you have a great rest of your week, and I will see you next Monday.